Hi everyone, I hope you are doing good. So today in this video we will take a new DSA question and this is regarding the tree boundary traversal. So first we will understand the question, then we will take some examples to understand the question clearly, and then we will discuss the solution, and then I will implement the solution, and I will show you the C++ code also. So this street boundary traversal is a very common question. It got asked in multiple interviews. So please watch the complete video so that the understanding will be should be clear, right? And you can address these questions easily in the interview. So let's start with the question first. So the question is given a binary search tree, one binary tree will be given and find its boundary traversal. We have to basically find the boundary traversal. The traversal should be in the following order. So here the order is given. First we have to traverse the left boundary, then leaf nodes, and then traverse the right boundary, right? So this includes the left boundary includes all the nodes on the path from the root to the leftmost leaf node, correct? And then you must prefer the left child or the right child when traversing. So do not include leaf nodes in this section. So for example, our tree is this one. This one. So what it is saying for left boundary, we have to include left. So this node we have to, right? And then this one. Yeah. So for left boundary, what we have to do? This includes all the nodes on the path from root to the leftmost leaf node. Right? You must prefer the left child or the right child when traversing. Do not include leaf nodes in this section. Right? So this is the leaf node. Right? So we will not include this one. So for left boundary, what will be the nodes? 1 and 2. Correct? And then we are including the root also from root to leftmost leaf node. Correct. Then leaf nodes, all the leaf nodes we have to include left to right order that are not part of the left or right boundary. Correct. So in the leaf node traversal, what are included? This is 4, 5, 6, and then 7. These 1, 2, 3, and 4. These are the leaf nodes. Correct. And for leaf node condition is left and right should not be there. Then right traversal, right boundary traversal, this includes all the nodes on the path from the rightmost leaf node to the root traversed in reverse order. Correct. So here in left traversal, what we did, this is not in reverse order. We are traversing from root to leftmost leaf. Correct. This way. Then here we are going from left to right, and here for right boundary traversal we are going basically in reverse order from rightmost leaf node to the root. Right, and root we have already included, that is what here mentioned. So rightmost leaf node to root traverse in reverse order. You must prefer the right child over the left child when traversing. Do not include the root, right, because root has been already included while traversing the left traversal, left boundary traversal. Correct. So that is why we do not have to include this one twice, root one. So here for right boundary traversal, what are the nodes? Only these three. This one only, correct? This is included as part of the leaf nodes, right? And this is included as part of the left boundary traversal. So that is why only one node is here. I hope you are understanding this one. Let's take one more example. And here one more node is given. If the root doesn't have left subtree or right subtree, then the root itself is the left or right boundary, right? So for example, in this case, this is 1, this is 2, this is 3, and this is 4, for example. So here right is not there, correct? So in this tree right is not there. So this root itself is considered as a right boundary. That is what it is mentioned here. The root itself is the left or right boundary, right? Left we have, so we will go here this side, then this side, and here we will not go right side because this is itself is a right boundary, right? And which got included while left boundary traversal. Correct. So I hope you are getting this. We will take one more example, like a separate example for this one. So here in this given example, what it is saying, like this is the binary tree, right? So this is we will go from this. This is the left, right? Left boundary traversal. Then this 4, 8, 9, 6, 7. These are the basically leaf nodes. right? And then this side is the right boundary traversal, right? Correct. So 1, 2, 4, 8, 9, 6, 7, 3. This should be your output. That is what it is coming here. This. Let's take another example. So here you can see here we do not have right node here, only left node is here. So this will be considered as the left part, right? This will be considered as the leaf, right? And right we do not have anything, right? So this 1, 2 and 4 will be printed as a left boundary traversal. Then 6, 5, 7 and 8 will be printed as a leaf boundary traversal. But right side we do not have any right side because that root node is not having any right node. Correct? So we will not print anything here this side. So the output is also same 1, 2, 4, this one, right? Then 6, 5, 7, 8. Correct? I hope you got it. So let's move to the another example. So here in the above example we saw there is no right node, and in this example here we do not have any left node, we have only right. So in this case what will be the output? Just think about it. Okay, so let me just pause the video and think about it, and then so here output will be, because we do not have any right left, so left boundary traversal will not be there, only root will be printed as a left boundary traversal, right? So 1, and then leaf node is there 4, correct? Then 4, this is left, this is leaf as part of leaf, and then right. So for right we will go from down to up, right? So 3 and 2 will be printed as part of the right boundary traversal. So the complete output would be 1, 4, 3 and 2. That is what it is given here. Correct? So I hope you are getting it. If left is not there, then you have to consider the root itself as a left boundary, and if right node is not there, right, then there is no right boundary. Basically, root will be considered as a right only, but root itself got included as part of the left boundary traversal. So yeah, so this is the question. I hope you understood it. Now coming to the solution, right? So think about the solution algorithms. What can be the algorithms? How can we implement this one in an efficient way, right? And if you have any different algorithm, any solution, then whatever I am discussing, then please comment below the video and let us also know about your solution. So what I have added, I just implemented whatever it is mentioned here, right? First left boundary, right? Then leaf node and then right boundary, correct? So this is my solution. So I have added some helper functions here instead of one single function. So what I did, I have added this is leaf node function here. So what it does, it checks it is a leaf node or not, right? For leaf node there is a simple condition, left node should be null and right node should be null, correct? And the node itself should not be null, correct? So that is why I have added these 3 checks here, correct? So if left and right is null, then that node would be considered as a leaf node. Okay, and then left boundary traversal here. So for left boundary traversal, what I did, if node is null, then I am just returning, or if it is a leaf node, because leaf node will not be considered as a left boundary traversal or right boundary traversal. So that is why if node is null or is the node is a leaf node, then we will return from here itself. Else what we are doing, we are just adding that node to the array, whatever the array we are passing, right, as a reference. So we are basically including that node data, right, in our result. So then after this, once we are included this data to our array, then we are checking if left node is there, then we will go to that node. Else if left node is not there, then we are basically going for the right node. So in this case, for example, here we have 1, then we have this is 2, right? Then we have 3, left is not there here. So as part of the left traversal, and here for example this is having 4, correct? So here in this example what should be the output here? And here for example 5, and then 6, this one. So here what should be the left traversal one is, first we have to traverse one route, right? So don't worry, I have included this route here itself. So in the main boundary traversal functions, I have first included, I have created this vector here, res, where we are storing all the nodes, right? Left, leaf, and right boundaries. And then here, if it is not a leaf node, correct? In that case, what we are doing, we are just pushing that into the result, this root arrow data. So now here, for the left boundary, yes, this one. So uh, I have added already one, right? One is already added, correct? Then I will check here and root. We have passed root to left, so we are here, right? So this is not null, and neither it is a leaf node, correct? So I'll add this data to res here. 2 is also added in the result, correct? And then I will check here node error left. So node error left is null here, right? So we will not go inside this condition. Basically, if we will go to else part, and else part we will check node error right. Node error right is there. So this node will go here and check. Again, we will call this one recursively. So this time the node is 3. This one, correct? So and this is not null, neither null nor a leaf node, correct? So we will add this one as a left boundary traversal, right? So this 3 also be printed, right? So we come here and from here to here, correct? This one, and now we will go from here, from 3. So now again this is not null, we have added this 3, correct? And then we will check node error left is there, yes, so we will pass this, but it is a leaf node, so we will not add this, correct, as part of the left boundary traversal. So left boundary traversal, what are the values? 1, 2 and 3, this one, correct? And then from here, this is leaf node, this is leaf node, this is leaf node, correct? So now coming to the this leaf node code here. So here also what we pass here, so let me tell you this one. This is the call right here. Add leaf node and root. We are passing root here. From here we will go and we left, and then we will check here. Yeah, it is a leaf node. We just print it. Then this is a leaf node. Yes, print it. And this is a leaf node. Just print it or add it into the resultant array. This res whatever we are passing, right? And for right node we are passing the root arrow right, because we are not including the this root value here, correct? So let me show you this code as well. So here, just understand. So we got the root. Now, if it is a leaf node, we will add. Else, what we will do? We will go and add the go to the node error left, right? So here root, it is not a leaf node. Then left, yes. It is not a leaf node. Then we will go left. It is null. We will come back and go to right. So we will come here. So this is a simple pre-traversal basically, right? Right, pre-order traversal. We just added one additional condition here. It should be a leaf node. Then only we will add it into the resultant array. Correct. So here, if it is a leaf node, then we will add this one 4. Correct. This is 4 added. Now from here it will come and here go right. Right is null, right? So from here it will go here, then it will come here, it will here, right? The root, and then it will go the right of the root node here 5. Correct. 5 is not a leaf node, then it will go to left. Yes, this is a leaf node, so it will be printed. Correct. 7 is printed here. Then it will go left. It will come back because left is null. Then left of 7, right? Right of 7 is also null, so it will come back. And this node already added, so it will come back to 5. 5. Then it will go to the right of the 5 node. This one 6. Correct. 6 is a leaf node, so 6 will be added to the resultant array. Correct, and then it will come back and it will basically come out from this add leaf node code. Correct. Then it will we are calling the add right boundary, right? Or last call is add right boundary. This one. Correct. So what it will do? It will go to this code, and here we are passing the root arrow right. So we are basically starting from here itself, right? Not from the root here, correct? So what we will do, we will go right, 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 and then in reverse order we will print this one instead of the this ascending order or from root to leaf. But here we have to print leaf to node, right? Rightmost leaf node to root node. This in reverse order we have to add basically the data, correct? So what we will do, we will do the right, we are coming here. So this node is not a leaf node, correct? Neither null nor nil leaf. So we will not return from here. Then here we will check node error right. Yes, node error right is not null. This one, correct? So what it will do, it will call this one here, but this is a leaf node, so it will come back and then it will print this one node, this 5. So here 5 will be printed. So I hope you understood this one. I did the dry run for you, right? So in this way we have printed 1, 2, 3, 4, right? 1, 2, 3, 4, then 7, 6, and then 5, correct? From here to here, here to here, right? And then we are coming out from this basically tree traversal. So I hope you understood this one. It is very basic, easy question, right? What you have to do here is you just have to follow the instructions whatever is given in the questions. Just check for the root null, then you have to check separate code for the left boundary, then write leaf nodes, and then right boundary, right? And then you can add all these to the separate array, and then you can basically print that array. Or instead of adding the array, you can print itself here itself also. That is up to you. So that's all for today. I hope you understood it. See you next time. Till then, keep learning and keep exploring.